Hello, everyone.
Hello.
Yes, good afternoon, everyone. Good afternoon.
Good afternoon.
Avijit, please turn your
Yes.
camera on if you can.
Hello. Hello.
Hello. Yeah.
Is that okay?
Yes.
Okay.
It's okay.
Good afternoon, everyone. So first of all, I want to welcome you all to join my online session, and wants to thanks a lot the management and the director to give me that opportunity to deliver the lecture and share my knowledge. Excuse me. Share my knowledge along with you. So today we want to discuss to you. We want to present a beautiful, knowledgeable part of the chemistry, that is uh, dative bonding or coordinate bonding. Okay. So I think you have already heard about the covalent bonding, and after the covalent bonding, I want to start today the dative bonding or the coordinate bonding. Okay. So do you have any question regarding covalent bonding that is from your previous chapter? Anyone? Anyone asked any question?
Please don't be shy. Don't be shy. Please ask.
Don't be shy, please. Yes. Don't be shy.
I thought we have biology.
Yes, you have.
No.
Yeah, but covalent bonding is chemistry, isn't it?
Covalent
Yes.
chemistry. Yes, absolutely right. But today we have a
Yes.
coordinate Indian Ukrainian lesson with the Mr. Avijit. He is a science teacher, and he shared his knowledge with us, and this is the collaborated lesson, and it was the most suitable time, so that's why we sat on the biology on one of the lessons on Thursday. So please be on chemistry now.
Okay. So today I want to start dative bonding or coordinate bonding, right? So first, what is dative bonding? What is dative bonding? For that, I want to share the screen. I have a presentation for you. Please look at that presentation, and one by one, I will let you know regarding the chapter and regarding the concept. Okay. Yes, here it is. So what is coordinate bonding? It is the bond between the two atoms. You can consider like they should be both are like atom, right? That is electronegativity of the both atoms should be similar. Okay, because as we know that if there is difference between the electronegativities between the two atoms, those are participating in the bonding, so there should be not a sharing of electron, there should be donating and accepting one. Those are most electronegative, that atom should attract electron towards itself, and those are the electropositive want to lose electron from their outermost shell, and after losing or gaining electron, they will form ions, and there should be some strong force of attraction between them, and that type of bond is considered as a ionic bond. But we are discussing here that is a coordinate bond. So what is coordinate bond? Before that, I want to let you know again what is covalent bond and why covalent bond is formed. Actually, covalent bond is found between the like atom. Those are both are electron negative by nature. That is, they don't want to lose electron from their outermost shell. They want to share these two, either one or two or 3 pairs of electrons between them. So there is a mutual sharing of electrons. When mutual sharing of electrons takes place between the two atoms of similar electronegativities, they are known as, very sorry, they are known as what? Covalent bond. Now, we have to distinguish between the covalent bond and the coordinate covalent bond. That is covalent bond and the dative bond. What is dative bond? Covalent bond is taking place between the two atoms, when a paired, more than one pair of electrons is shared by the two atoms, but the electron comes from both the atoms. Suppose A and B, both the atoms are participating in a covalent bonding. So in case of covalent bonding, an electron comes from A, another electron comes from B. They are forming a pair. This pair of electron is shared by the both A and B, and there is a single bond. If one pair is shared, there is a double bond. If two pair is shared, there should be triple bond. If 3 pair is shared, that is covalent bond. But when suppose A and B are participating in the chemical bonding, but a pair of electron comes from either of A or B, not from A and B both, only from A or B. That depends on what? That depends on their structure, their electronic configuration, their how many electrons are there in the outermost cell. Depending on that, we have to decide which one is the donor atom, which one is the acceptor atom. That is, for dative bond or coordinate bond, there should be an arrow pointing towards donor to acceptor. Suppose between A and B, there is a bonding, dative bonding. So you have to remember that there should be arrow pointing towards A to B, because we have to show that A is donor and B is the acceptor. So in that particular case, A should have a pair of electron. A should have, please remember that point, A should have a pair of electron, that is a lone pair of electron, and B should have less electron, minimum 2 less electron in its outermost cell. That's why B has a tendency to accept a pair of electron towards itself, and A has a capacity to donate a pair of electron towards the B, and that's why there should be a bond between A and B. How will you know which one is donor and which one is acceptor? That's only simple by giving an arrow between A and B. There should be arrow pointing between A and B. Okay, so what is the difference between the covalent bond and the dative bond? Very simple. Both are sharing electrons, but for covalent bond, a pair of electron is used for the sharing. It comes from the both of atom A and B. But in case of dative bond, a pair of electron comes from either of A or B. That depends on their electronic configuration. That is, which one have octet clear, which one have less, that is than the octet. That is, they have less than 8 electrons in their outermost cell. So as we know that every atom want to lose or gain electron from its outermost cell for only one reason, that is to get stability, to get the nearest electronic configuration of the noble gases. They want to lose or gain electron. Okay, is that clear to all? Any question regarding that? Any question?
No questions.
So that's why it is given here. A single covalent consists of a pair of electrons shared between the two atoms that I already told you. In most covalent bonds, each atom provides one of the electrons, but in some bonds, the atom provides both the electrons. This is called the coordinate bonding or dative covalent bonding that I have already told you. So in case of dative bonding, one is donored, another is the accepted. Why? Due to the difference of their electronic configuration, because one is saturated by the electrons, another is not saturated by the electrons. One has capacity to donate, another has capacity to accept. That's why one is donating electron, a pair of electron, another is accepting a pair of electron. That's why there should be a bond, but one is donor, another is accepted. That's why we have to put an arrow pointing towards donor to accepted. Clear? Is it clear to all?
Yeah, absolutely.
Okay. Now, I have already discussed in the class what is covalent bond and what is dative bond. Now you need one example for understand that. Look at here. Look at here. That is, this is the structure of. Look at the screen. This is the structure of the ammonia molecule, right? NH3, and it is given by the cross and the dot. Okay. So it is the ammonia, and you have to consider H plus atom. That is H plus. What is H plus? Very simple. I will let you know what is the difference between the atom and the ion. What does it mean by the H plus ions? H plus ions means when hydrogen atom, that is neutral hydrogen atom, losing one electron from its outermost shell, it will form H plus, because when atom loses electron, they will form ion. They are considered cation. And when atom accept electron, they are forming ions, but they are known as the anions, right? So this hydrogen atom, as we know that the atomic number of hydrogen is 1. So it has one proton in its nucleus, and it has also one electron in the outermost shell. So hydrogen loses one electron from its outermost shell. There is no electron in the hydrogen atom. Okay. So if there is no electron in the hydrogen atom, so hydrogen want to accept 2 electron, because as we know that in first cell, maximum number of electron can accommodate is 2. Maximum number of electron can accommodate is 2. So hydrogen has, that is H plus ion, has a tendency to accept a pair of electron. H plus ion has a tendency to accept a pair of electron. So when H plus ion will combine with ammonia, look at the picture. In case of ammonia, it is denoted by the green dotted. This green dotted indicating that this ammonia, that is nitrogen atom, contain a pair. It is a lone pair. What is lone pair? Lone pair is what? This lone pair is they are not participating in the bonding. This lone pair are not participating in the bonding. They are free. They are available. So in case of ammonia, there are 2 electrons. That is a pair of electron. Lone pair. They are considered as a lone pair. And on the other hand, hydrogen atom, hydrogen ion, rather to say hydrogen ion, it has no electron in its outermost shell, but it has a tendency to accept a pair of electron. Why so? Because to fulfilling its octet. But in case of hydrogen, it should be duplet, not octet. In case of hydrogen, it should be duplet. Okay. So hydrogen need 2 electrons. From where? Hydrogen will take 2 electrons from nitrogen only, because nitrogen has a lone pair. That is, this lone pair is not participating on the bond in the bonding. These are the free pair. So nitrogen will donate a pair of electron to the hydrogen, and that's why they are forming. Look at here. They are forming what? Ammonium ion, and that's why between nitrogen and hydrogen, there is arrow pointing. Look at here. There is arrow pointing between nitrogen and hydrogen. This arrow pointing is due to what? For the formation of the coordinate covalent bond, that is dative bond. Because why there is the arrow pointing towards nitrogen to hydrogen? Because here hydrogen is accepted. It's accept 2 electrons from the nitrogen, and nitrogen is a donor because it donates a pair of electrons, and after that they are forming ammonium ion. Clear?
So
that-
can I give some summary, please, dear
Sure.
students?
Please.
So please, dear students, I want you to remember the covalent bonding. So please answer me now. What is the main? What is the main in the covalent bonding? We have 2 atoms with 1 unpaired electron, and they decide to pair their electron, and so we have our covalent bonding. But in our dative bonding, it's more related to the organic chemistry, we have the 1 pair, and another atom has the place to keep those pair, and that's why it's one of the part of the covalent bonding, that's why we come into the practice. Please, Avijit.
Yes. That's right. So can I start? Can I
Yes.
continue, ma'am?
Yes.
Okay, thanks. Now the next example, that is formation of H3O plus ion. Go to the second example of this page. When H2O is combining with the H plus, it will form H3O plus. Look at the arrow pointing. Look at the structure of the water molecule. In case of the water molecule, consider the central atom oxygen. It has 2 lone pair on it. Now there is arrow pointing. This oxygen will donate a pair of electron towards the hydrogen. As I told you earlier, hydrogen H plus ion has no electron. It has a tendency to accept a pair of electron. And in case of oxygen, there are 2 lone pair on it. So oxygen has a tendency to donate a pair of electron towards the hydrogen. And that's why it will form a coordinate bond along with the hydrogen. And there should be 1 arrow pointing towards the oxygen to hydrogen. And the plus charge will goes to that particular atom only. That's why it is denoted by H3O plus. H3O plus. This is the similar like ammonium ion. Here, in case of ammonium ion, nitrogen was the donor atom. Here, oxygen is the donor atom, because in case of nitrogen, there was 1 lone pair on it. In case of oxygen, here the 2 lone pair on the oxygen atom. So it has a tendency to donate pair of electron towards that atom which has less electron density, which has a tendency to a pair of electron to fulfill their octet or duplet. Is that clear to everyone? Any question regarding that? Hello?
No,
Any
no questions.
Yeah,
No
everything
questions.
is-
No,
Are you sure you really
no
have
questions.
questions? Are you sure? So we can go to the questioner, Avijit.
Yes, please, ma'am. You can start the session. Before that, just I want to share this one also. The formation of AlCl4 minus ion. The formation of the AlCl4 minus ion. Look at the screen carefully. Look at the screen carefully and let me explain the total fact regarding the formation of the AlCl4 minus, right? Look at the screen. First, consider the structure of the AlCl3. AlCl3, here the central atom is aluminium and its atomic number is 13. Its atomic number is 13 and the configuration is 283. That is, in the first cell 2 electron, in the second cell 8 electron, in the third cell 3 electrons. So third cell means outermost cell. There is 3 electrons. Okay. Now, in case of aluminium, it has 3 electrons in the outermost cell. Now, aluminium is combining with the 3Cl atom to forming the AlCl3. So it will share 3 electrons along with the 3Cl, and that's why now in case of AlCl3, total number of electrons surrounding the aluminium atom is 6. That is given there. Total number of electrons is 6. Still, aluminium does not complete its octet. It has 6 electrons in outermost cell. So it needs 2 electrons. From where it will get 2 electrons? Look at here, this Cl atom. This Cl atom is carrying a pair of electrons. Cl minus means it will carrying a pair of electrons. When it will combining with this AlCl3 and this Cl minus, they will form AlCl4 minus. And here also there is the arrow pointing towards Al2Cl. Why this is Al2Cl? Because it will form a coordinate covalent bond, because here Al is donor, Cl is acceptor, right? Yes or no, everybody? Yes or no? Hello?
Yes.
Hello?
Yes.
No,
No.
this is wrong. This is wrong. I want to
Yeah,
I
yeah.
want
No.
I want to test you all, because what I have told, I told you here Al is the donor, Cl is the acceptor, but it will be not, it will be reversed, because Cl is carrying a pair of electron. Al has incomplete octet. So the bond between AlCl3 will be Cl is donor, Al is acceptor. I am repeating again here. Cl is donor, Al is acceptor. That's why look at the picture carefully. The arrow pointing towards Cl to Cl to Al, not Al to Cl. Okay.
Yeah, we
Okay.
understand.
Yes. So arrow pointing was Cl to Al, not Al to Cl. So you have to look it carefully.
It was wrong, yeah.
Okay, please listen carefully for your betterment. We're doing that class for your betterment, for the revision of your study. So you have to be careful. You have to be dedicated in the class, because you have to know that the relation between the teacher and the student, it is a both ways traffic, not the one way. It is also between the like the bonding, donor and acceptor. Is that clear? I am right or wrong? What do you think? Hello, everybody.
You're right.
Okay, thanks a lot. Thank you. Okay, the next part, after completing the AlCl4, we have to go the next part. Look at this one. That is what pH3. pH3. The name of the compound is phosphine. pH3, like ammonia, NH3. So this is phosphine, that is pH3. Look at here. How many electrons are there? The question is that how many electrons are there in the outer shell of a P atom? P stands for phosphorus. Repeating again, P stands for phosphorus. The atomic number of phosphorus is 15. So its configuration is 285. So in outermost cell, there are 5 electrons. So the answer is 5 electrons are present in the outermost cell, right? Okay. So when phosphorus, this is P, will combine with the 3 hydrogen, it will form pH3 or phosphine. So each hydrogen will carry 1 electron, and this P has 5. 5 plus 3 will make 8. Like that way, phosphorus will complete its octet. And that's why there should be what? There should be 3 single bond between P and 3 hydrogen. That's all for the first point. Now, when pH3 will form what pH4 plus ion like ammonia also. So what will be the result? Very simple. This pH3 when combined with the H plus ion, P has a lone pair on it. P will donate a pair of electron towards the hydrogen atom. After donating that lone pair, they will form a coordinate bond. After formation of the coordinate bond, they will form pH4 plus ion. And for denoting that which one is donor and which one is acceptor, there should be arrow pointing towards phosphorus to hydrogen. That is given there in the picture below the table. That is given here pH4 formation, and this is there is a arrow pointing towards P2 hydrogen. Okay. Any question? Anybody? Do you have any
No,
question?
no questions. No questions.
Sure.
Yes.
Okay. Go to the next one. So this is also given there. The structures. All structures are here given step by step. All structures are given here. Look the screen carefully. Next, this is also given here. Now, ma'am, I want to request you, you can start the question and answer round.
So, and the question and answer. So, you need to revise bonding, and if you do not understand, must come to see me. And so, use dot and cross diagrams to show the bonding in the following molecules. Please take your notebook if you wish, or take your any interactive way to do this. So, use dot and cross diagrams to show the bonding in following molecules. So NH3, so it's the ammonia molecule, as you remember. And who is here? So I propose you to, remembering about the NH3, and who want to do this on our blackboard? I mean, on our blackboard. So maybe
first, let me know what will be the product when NH3 will form
I
with
can do
the
it.
combine with the H plus.
so, and who can do this?
Me. I can do it.
Okay.
What's your name? What's your name, please?
Andrew. My name is
Oh.
Andrew.
Okay. Nice to meet you.
So Avijit,
Oh,
I ask you to stop the sharing the screen, and I'm gonna share the desk, the blackboard,
Sure.
and we have the 10 minutes only.
Okay. I have already shared the blackboard.
so, can I draw?
Yes, start.
Okay, so as you learned in previous school, there's like one atom of nitrogen, and there are 3 atoms of hydrogen, and it's something like this. Like this.
Okay, this is the ground state configuration of nitrogen atom only. Now, how it will form NH3 along with the 3 hydrogen?
Oh,
Okay, like that. Now you have to point out the which electrons will come from the nitrogen and which electron is come from the hydrogen. For denoting that, you have to use
I remember.
cross and dot. Yes, yes. Cross and dot.
Share. If they share, then it's like this, and dot,
Yes,
and
yes,
here is
yes,
also, and here
yes,
is also like this, cross and dot, but here they
yes.
don't share, so there's two dots, like this.
Yes, yes, absolutely right. And
Very good, very good.
And for H, hydrogen also.
You have to bring one H plus atom ion from the outside.
mhm,
I,
yes, because H plus have no electron. So that's why it's dative bonding, because our nitrogen has the two electrons, one electron pair, but hydrogen has no any electron pair, no any electron. I mean hydrogen plus, hydrogen proton. Andrew, don't worry, you're absolutely right, but just it's missing. Yes, cross and dot.
Yes, yes.
Mhm.
Mhm.
So great, congratulations, absolutely right. So applause.
Very
for
good, very good,
Andrew.
very good, very good. So
Applause,
absolutely
yes,
right.
absolutely. So Avijit, please share the previous presentation to the next.
Sure.
I mean presentation to the next task. Yes, thank you.
Sure.
Yes.
Hmm.
So
Next one is the formation of H2O plus, H2O and H plus. Yes, please.
yes, who want to? Helen, do you want to? Let's try.
Okay.
You know, this topic is like really hard for me. I don't understand it at all.
no, this topic is very easy. The topic that we are learning now is way more harder.
So don't worry. So you're the first of all, you should write down the dot and cross diagram to H2O. And next step, you need to find the electron pair on cross dot diagram. So unshared electron pair, and then you add the hydrogen to this unshared electron pair. So, and on question B, they're asked to recognize and to find out how our hydrogen ions formed. I mean, hydroxonium ions formed. Hydroxonium.
Yes,
So
yes.
it's a new topic for us, but don't worry, it's very connected with organic chemistry. In organic chemistry, you will have a lot of problems used like this, looked like this. So please, Helen, don't be shy. I believe in you. You're one of the best students.
But I can do it.
You can do it, Andrew.
Maybe we'll let Andrew do this again.
So maybe Andrew need to share their knowledge. So Andrew need to share knowledge with Helen or and with and the rest of the classmates. Andrew, come on, so share your knowledge.
But
Sure.
it's easy.
Now go for the
Tell
third
us how
one.
you do
It
it.
is the C one.
So I
What
propose you to do this in pairs, Andrew and Helen. So Andrew, start and
So, but look, Helen, like we have one oxygen atom and two hydrogen atom. We just basically draw it. Like I better draw it here an oxygen atom, and here are two hydrogen atoms.
yes, and you need to put the cross dot diagram.
Yes, like when they share their like this thing, the circle, then there will be a cross and a circle. And here's also, and here's two
Yes,
circles.
but listen carefully. But one thing, listen carefully. When you have to draw the structure of the water molecule, please remember that don't have to write the hydrogen in horizontally. That is, they are not lying in the same plane. Please remember that two hydrogen and one oxygen, they are not lying in the same plane. They should be angular by nature. So bond angle is angular. So you have to consider when you want to write the structure of the water molecule, the two hydrogen atoms should not be lie in the same plane along with the oxygen. So they should be there in different plane. So please remember that. Okay.
Okay. It will look like this, and then we just add another hydrogen.
Yes. 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 So between this oxygen and hydrogen, you have to put an arrow pointing, because here oxygen is a donor and hydrogen is the acceptor. And hydrogen is not ordinary hydrogen. This hydrogen is H plus. Okay, and H plus is considered as the proton. It is proton, because when hydrogen loses one electron from its outermost shell, its charge is positive, unipositive charge, and that's why H plus ion is compared as a proton. Remember that, please. And what should be the third one? What should be the third one between the bonding between NH3 and BF3? I want to let you know, very simple thing is this. NH3, just consider in case of NH3, the structure of NH3 is very simple. It has a lone pair on the nitrogen atom. And in case of BF3, what is the atomic number of boron? You have to consider. It is what? It is 5. So there are 3 electrons in the outermost shell. So that's why it won what? When B, that is boron, combined with the 3 fluorine atom, it has 6 electron outermost shell. So to get octet, it needs 2 electron. From where it will get? It will get from the nitrogen atom. Nitrogen will share a pair of electron towards the boron. Okay, and that's why boron will accept a pair of electron, and that's why there should be arrow pointing towards nitrogen to boron.
So I'm so sorry, because we have less than a minute, and I want some reflection from students. Please take some reflection. Please be honest. Tell me what you don't understood, and let's talk about this. And turn your camera on. Don't be shy. Tell truth. So what wasn't clear? So maybe we should start.
Oh, I think that
what was? Yes, of course. Come on.
I think that everything was really clear, and also the explanations were really fine. And I don't know if others, but I don't need to refer back to this theme, because in law school we learned it all this semester. So I think I'm fine with this topic.
Okay, thank you. Maybe someone else, maybe Polina, Anna, maybe Dasha. Please, maybe Matvey.
No, everything's clear. Yeah.
Everything clear? Okay.
Ребята, а вы какие-то гении, я что-то не пойму. Как вам может быть everything clear? Мне лично ничего вообще не clear. Вот, типа, у меня нормальные знания с химией, но, блин, эти бондингс у меня, наверное, на всю жизнь останутся незаконченными, потому что, блин.
So we will finish this on the next lesson. Don't worry, Helen. I will correct your knowledge. Don't worry. So please, we need to know. So is it? So what word can you take from this lesson? One word. Just one short word. Please don't be shy. Жанна, Полина, Демид.
Bond.